Watch what's happening. This is what's happening here. We're on the right side of the right side pack. It's manipulating these valves through their range of motion as part of the test. And this is the one that I'm concerned about, is this ram air inlet valve, which shows that it's in the closed position. 0.98 is closed. Alright, so as soon as that test is finished, I'm going to run a special function and open that valve. And there you can see the valve is actually opening again. It's part of the test. They close those to keep the pigeons out. Especially here in the desert, there's no place for the pigeons to hang out of the shade, and so they'll crawl in anywhere they can find. Alright, the valve is fully open. Let's check the test. Alright, the test is still operating. There, the test is still operating. Wait for it to finish. There, it's closing the ram air door in stages. It's at 30% now. Alright, so that test passed. Now what I'm going to do is go to this other functions, down to the special functions section. Cabin temperature control. Right. Let's see, open the right ram door, continue, and it comes up with the conditions of the test. Really no conditions for this to run it, so I'm going to open it now. Alright, it says everything's met, all the conditions are met, start the function. Now it's operating the motor to drive the door open. Alright, it's completed. Alright, now that door on the right side of the airplane, that ram inlet door is open. We'll exit the maintenance functions. Alright, now this is the air conditioning system. This shows all the different zones. That's the flight deck. And then we have zones A, B, C, D, E, F, aft cargo, and a bulk cargo zones that we can control temperatures in. And that's our target temperature. That's where we set the temperature that we want to be at in that room. Well, that's the zone. That's the current. The zone temperature is the current temp. Target temperature is the one right below it. It's what we're actually targeting, trying to get the temperature to control to. And then the duct temperature is what's actually in the duct. And what that number is composed of is the cold air that comes from the pack down here, blows into the duct, and then this trim air valve mixes hot air from the APU or from the jet engines into the duct to get the right temperature. And so these trim valves will modulate open and closed, because the air that goes from the packs is about 32, 33 degrees Fahrenheit, which would be freezing, obviously. And then the pack will introduce, or the trim valves will modulate based on commands from the cabin temperature controller. It will modulate the amount of warm air that it mixes in to get to the target temperature. And so you can see what the duct temperature is actually doing inside there and where your trim valves are. Then we have recirculation fans, upper and lower, forward and aft. And then these are actually the packs where the air is controlled through or conditioned through. And we'll see those come to life here in just a minute. Right now they're just reading ambient temperatures. We've got the left one and the right one, and then more data, the left one and the right one. Alright, now what I'm going to do is turn on the packs I'm going to turn on the, actually let's open these. These are the outflow valves that we saw on the outside that are closed. They're in manual position right now. That's them starting to move in the middle where it says forward and aft, OPCL. M stands for it's in manual mode, and I'm moving them to the open position. Now when we get in flight, those will automatically modulate to control the pressurization inside the cabin. If we get too high a pressure, they open up. If we get too low a pressure, they... And I'm moving them to the open position. Now when we get in flight, those will automatically modulate to control the pressurization inside the cabin. If we get too high a pressure, they open up. If we get too low a pressure, they will close. All right, now we'll put those into automatic mode, and from now on they will operate automatically. And this is the APU bleed air. These are the engine bleed airs. Obviously we won't have those on right now because the engines aren't running. When we go into flight mode and the engines are running, these take over and this is shut down. And then you can see on the panel, the system schematic is drawn on the panel to what it feeds to. This is the wing anti-ice. These will be like the leading edge that I showed you on the engine and the leading edge of the airplane. The leading edges of the horizontal and vertical, all the shiny metal on those is the heated leading edges. So that'll be wing anti-ice. So that goes to those valves. All right, we're going to turn the APU on, or the APU pressurization on. Let's go to, what I'm going to do here is we're going to move to the center screen. We're going to display the air. This green right here is the APU, shows that it's running. Now I'm going to push this button here. See the APU valve opens. All the isolation valves opens. Duct pressure charges. All right, now the duct is pressurized. It's got 24 psi on the left side and 27 psi available on the right side. But because there's no flow, it's not indicating it in green. All right, so now what I'm going to do is turn on the left pack. That's this button. And it's going to control up here. As soon as I turn that on, the air will start to flow, and the lines will turn green. All right, so that's our air that goes into the pack system. Then we have an air, this is hot air coming out of here. This is several hundred degrees, maybe 400 degrees or more, 450 degrees. Very, very hot air coming off of the jet, off of the APU engine. And so hot air goes in there and hot air goes this way. And this air is going to get cooled down and come out at about 32 degrees Fahrenheit. And the air that goes this direction is the trim air. That's going to stay hot, and once this air comes out and goes into the duct, this air will be mixed into it to control the temperature, and that's how that works. And this is a complicated system of stuff. Basically what it amounts to is you run air through a turbo, like on a car turbo, backwards. You know, when you run air through a turbo, normally on a car it compresses the air, which increases its heat. But when you run air through a turbo backwards, it expands the air and reduces the temperature of the air. As expanding air loses its temperature, just the way it works. Physics. And so that's the principle of the way the air conditioner works. You just run the air through a turbo backwards. And there's a big turbo down there, which just screams like a son of a gun. We'll go down there and hear that later. Alright, so now what we've got here, we've got our pack volume, our pack flow volume, the mass. Our outlet, pack outlet temperature is a -4 right now. And our pack inlet temperature, see that's this air right here going in, is at 349 degrees, 348. That's at the primary heat exchanger. Let's see, primary heat exchanger output, so it drops it from 350 down to 196. The compressor outlet temperature is 251. Secondary heat exchangers down to 91. So by the time we go through 2 heat exchangers, we've dropped the temperature down to 91 degrees. Now we've got a condenser in there that takes moisture out of the air. It's running at 33 degrees. Stage 2 turbine inlet temperature, 57 degrees. Trim air pressure is running at about 5 psi in the duct. This says that pack control is being done by channel 1 by both of these. We have 2 channels, so if one channel fails, the second one will take over. Pack inlet pressure is at 39.6 or 42.3 psi. So that's the duct, that's the pressure in the duct. This one's lower because it's open and flowing right now, and this one is still closed. That's why it's a higher pressure. When we open that one, it'll start to flow and the pressure will reduce some. That's flowing 39 psi through a 6-inch pipe. That's a lot of air flowing through. All right. Lower limit valve, it shows its position. Turbine bypass valve shows its position. Those are all open. Ram air inlet valve, or inlet door, that's open. Economy cooling valve is closed. Lower flow control valve closed. Upper flow control valve open. All right, now we're gonna push the other button and we'll see what happens here. Now you can see that the temperatures drop, or the pressure has dropped as the load has been split by 2 packs. Now we've got 2 packs flowing. This one's building up its flow as all the valves start to open and that air starts moving through. Temperatures are increasing. The pack outlet temperature, as the pack starts to operate, begins to drop pretty quick. You can see that the trim air valves are modulating as they work to introduce the hot air into the cold air inside the duct to achieve our target temperatures. And so you can see the different duct temperatures. This one's at 64, at 70, at 46. This one's at 80 because he's reading that he's below, that this zone is below temperature, so he's trying to raise the temperature in that zone. These are trying to lower the temperature in their zones for some reason. And let's see. Now the temperature that we're getting right now is these 2 packs. They dump their cold air into what's called the mixed manifold. The mixed manifold is a giant manifold. It's just a giant cylinder with a bunch of pipes coming into it from different sources. And these 2 big pipes coming into it, and then there's a number of pipes going out as it distributes the air. So that's actually at 48 degrees right now. A lot of times that will get down to 33, 34 degrees. And so we got 48 degree air being dumped in to the ducts. Well, you can see it right here. This one's still at 48 degrees. So he's dumping in full cold air straight off the packs. The valve is closed in that position. And then these are dumping in different quantities of hot air to mix in with that 48 degree air. And these back here, they're controlled separately, and they'll just get dumped in to keep them at close to 45 degrees.